Hello guys, this is the First Motion Lab channel, relocated. Please subscribe to be posted on our new projects. A lot of things have happened in the world since our last video was posted, and the world thing is the assault of Russia on Ukraine, of course. That affected us, and we have changed the country to be able to live, develop our projects and assist countries to keep independence. And now let's have a start. In our new place, the first problem we have met is an electric power supply. We can find any solar panel, big, small, monocrystalline, or polycrystalline, more power, low power, any kind you want. But if you don't need to build up a full energy system right now and need just to do some work, that is difficult to find powerful step-down DC-DC converter to be able to make direct connection between solar panel and load you need. That is okay. If we can't find what we need, we will do it yourself. Let's have a start. First of all, we need to make a circuit board. The circuit board must be big enough to put at least 3 powerful transistors. It seems to me that 146 by 100 mm is a normal size for our aim. The thick of this board is 2 mm. In the beginning, we have to use sandpaper to remove oxide film. For this, better use fine or superfine sandpaper to avoid deep scratches on the surface. In the next step, we have to remove the dust, fat, and other dirt from the surface of the board. I think that alcohol is one of the best choices for that, but other liquids can be used, of course. Now our board is ready, and we will print our circuit on it. I will use the Proto software to create the circuit of DC-DC converter. This device will be based on the TL494 pulse width modulation control circuit, because this is a well-known circuit, reliable, has a low price and easy to use. For exit power case, we will install 3 NPN type BJT transistors TIP35. I'm not going to show here how to use Breteo software. Everyone can find a lot of lessons in the network, but I think it can be important to show what kind of pulses we must get on the circuit. If you have the solid type pulse on pin number 5, it means your circuit is working. But if at the same time you have no pulse on pins 8 and 11, you have to look at the feedback pins and pin number 4. On this simulation you can see the square exit signal, red channel on the oscilloscope, but in real, the signal form will not be square and depend on Drossel and capacitor. Now is the time to put our components on the board. That is really interesting manipulation, and at the same time it can take you longer than you could think. To avoid mistakes, better to have all real 3D models of the components you are going to put on the circuit board. And these 3D models must have the real position you want to have on the device. That's okay, let's have a look at the virtual model of the converter. I think it looks good. By the way, my solar panels give 36 volts. Therefore, I can't use operational amplifier directly in this case. That is not necessary here. Let's print our circuit. It looks good. I'm gonna try to cut it right by borderline. You have to use laser printer for this purpose, and better use special paper. I will leave link on sample of that. But I used photo paper, and I think I got pretty good result. Let's find our board and try to match them together. Not bad, I think. To fix the print on our board, better use adhesive tape. We will be sure that nothing will move in the future. The printed sheet must have the same size the board has, to avoid sticking adhesive tape on the copper surface. Okay, now our sandwich is ready and we go to the next step. The next step is carrying off the printed circuit to the copper surface of our board. And to avoid damage to the table and the sole of the iron, we must cover the table's surface and board. Now we need the iron. The iron's temperature must be adjusted to maximum. Just put the iron on our board and press with your hands. To hot up the board, you have to keep the iron under pressure for 1 minute or little more. Now let's look at it. That is good. Printed sheet didn't move, which means our circuit was carried off correctly. Our circuit is ready, and now we need to remove the paper from the board. To do this, we put the board into the little bath and fulfill the water. But you must remember, the board is very hot. Let it cool down for a couple of minutes before you pick it up with your hands. The water's temperature doesn't matter. Use water to be comfortable for your hands. Don't hurry up with it. Keep the board in water 3 or 5 minutes, and as you can see, it's easy to do. Use the water and step by step remove the paper from board. Now we can see the result of our job, and it's very good. All the roots of our circuit were carried off on the board, and we have lost nothing. You must check all tracks very carefully to don't miss some small pieces of paper between them. And now, the board is ready for the final step. To finish our job, let's take one small bath more and make some solution in it. First of all, we take hydrogen peroxide and pour it into the bath. And then we need a couple of spoons of the salt. The hydrogen peroxide and salt are mixed in the bath, and after that we take a couple of spoons of citric acid and add it into our solution. The solution is almost ready, but we have to mix it while the liquid becomes clear. Neither crystals of salt or citric acid must not be. All what we need to do now is just put the board into bath and watch how solution will work. And let's do it now. That is really interesting to watch how the solution is dissolving copper and getting a Caribbean green color. The dissolving process is not quite fast and depends on the quality of solution, its temperature and thickness of copper surface. The total process of dissolving copper surface takes from 20 to 60 minutes and even maybe longer. If you can see that the dissolving process is too slow or maybe stop at all, you can try to warm the bath up, but don't make the solution too hot, and try to keep the temperature not above than 60 or 70 degrees Celsius. Our job is almost finished. We just need to remove the toner from the board and clear it with the sandpaper. To remove the toner, I like to use acetone or some solvents based on it. Our circuit board is ready and we can start to drill holes and install components on it. In the next video we will build up our device and we will use it with its purpose. Thanks for you watched this video and we are waiting for you shortly.